Hello, we're doing checkpoint 5.20. They want us to use polar coordinates to find an iterated integral and then find the volume of the solid enclosed by the paraboloids. Z is equal to x squared plus y squared, and z is equal to 16 minus x squared minus y squared. Let's first take a look at what this region might look like. We have a right side up parabola starting at the origin. And then we also have an upside down parabola starting at 16. And so somewhere along the line they will intersect, and then you will have the parabola that you're, well, not the parabola, but the intersection here. And then you'll have the volume that you're looking for that's just going to be within these two parabolas. Now, between those two parabolas, you're also going to have to restrict yourself to whatever this intersection happens to be. And that's going to be an important part of our solution here. So if we look at the shadow on the xy plane that this is going to make, we're going to get essentially this intersection projected down onto the xy plane, and we will need to know what that is. So to find that intersection, it's where the z parabolas equal to each other. So we have an x squared plus y squared is the bottom parabola going up. We want to set that equal to 16 minus x squared minus y squared. That's the upside down parabola going down. So if we bring the x squareds plus y squareds over to the other side, we're going to have 2x squared plus 2y squared is equal to 16, or x squared plus y squared is equal to 8. So this has a circle, a radius, not 8, but actually the radius is square root of 8. All right, now we have ourselves a circle, and we want to find the volume here. So we want to see what's happening on the shadow of the xy plane. And instead of writing this, you can write it in terms of x and y, but instead of writing it in terms of x and y, let's just go directly to polar coordinates. And your r is just going to go from 0 to the radius, which we found to be square root of 8, and then your theta goes from 0 to 2 pi all the way around. Okay, now to find the volume, we'll say the volume is going to be the integral over the domain d of the difference between these two, and we have to know which one's on top. And so the function that's on top is going to be the upside down parabola. That's a 16 minus x squared minus y squared. And then the function in the bottom is the x squared plus y squared, and dA. Okay. All right. So we can continue to set this up by setting it up into the polar coordinate business that we have, and we'll do the r. They're both constants, so it doesn't matter what side we do first, but we can do the r on the inside. We're also going to write this in polar coordinates, so let's quickly take a look at how this thing will simplify. If we subtract it, we're going to get a 16 minus 2x squared minus 2y squared, but we want to factor out a 2, so it would be 16 minus 2, and then x squared plus y squared is r squared. So this is going to be the expression that we want to use in our integral. So we will have a 16 minus 2r squared. Now the dA will produce another r, and then we'll integrate with respect to r from 0 to square root of 8, and then with respect to theta from 0 to 2 pi. Okay. All right. Now we also would like to take advantage of the fact that these are constants and there's no theta in here, so we can move theta outside 0 to 2 pi of just d theta, and that's just going to be 2 pi. We will see this enough times where we'll just remember that that's equal to 2 pi. R goes from 0 to square root of 8. This time we'll distribute. We got a 16r minus 2r cubed dr. That's a dr at the end here. And then we just figure this out. So we will have a 2 pi from this first integral, and then we will integrate this. This is be 16r squared divided by 2, so that's 8r squared. And this is r to the 4th times negative 2, so it's going to be negative 1/2 r to the 4th. And your r is going to go from 0 to square root of 8. So 0 would disappear, 8. We have 2 pi times 8, and then square root of 8 squared is 8. And then we have a 1/2. Square root of 8 to the 4th is going to be 8 squared, which is 64. And then we have 64 minus half of 64 is 32, and 64 minus 32 is equal to 32. So this is 2 pi times 32. So that's 2 pi times 32 is going to be 64 pi. So the volume between these two paraboloids will be 64 pi units. Okay, I hope that helps.